What we're going to talk about today is another method of inference in statistics, and it's called hypothesis testing. And with this combined with confidence intervals are really the two big things. And I want you to look at this first problem. It said a study published in the Journal of the Air and Waste Management Association reported that the mean amount of PM produced by cars and light trucks in an urban setting is 35 milligrams of PM per mile of travel. Suppose that a new engine design is proposed that is intended to reduce the amount of PM in the air. There are two possible outcomes that could happen with the new engine design. Either the new design will reduce the level of PM or it will not. And these possibilities are called hypotheses. One of the hypotheses is called the null hypothesis, and the other is called the alternate hypothesis. What the null hypothesis states: it states that a parameter is equal to a specific value, mu naught. The null hypothesis is denoted by HO. What the null hypothesis would be for this problem, HO, the null hypothesis, it's always about a parameter, never about a statistic. It's going to be HO, mu is 35. That means that this new thing that they've done, the new adjustment, hasn't done anything. And the alternate hypothesis is denoted by H1. And there are three possible alternate hypotheses. And what I want you to do is draw three normal curves, please. So I want you to draw three normal curves right on this side of the bullet. And what I want you to put for the mean of all of them is our HO, 35. So I want you to put a 35 for all of them as the mean. All right, and the first hypothesis, the first type of alternate hypothesis would be something like, I think the true mean is less than 35. All right, and I want you to say that you got a sample and say that your sample result was 33, which is less than 35. I want you to go on your curve and I want you to put a 33 here. And this is a left-tailed test, so I want you to shade this way. And this, like I said, is left-tailed. You think that the parameter is less than HO. Now the next one. Another possibility would be, okay, I think for H1 that mu is greater than 35. All right, and say you took a sample result and your sample result was 37. So I want you to put a 37 on your curve. And I want you to shade this way. We're shading each time the way the arrow points. This is right-tailed. And I think that the parameter is greater than HO. And the last one is, I don't want to commit to less than or greater. I just think that it's different. So I think the parameter is different than 35. And let's say that you got a sample result of 33. So let's put the 33 here. What you're going to do where it's not equal to, I'm going to take my 33 and I'm going to shade this way. And I'm going to say 33 is 2 from 35. It's 2 less than 35. I'm going to go 2 greater than 35 and put a 37. And I'm going to shade this way. If I had started with the 37, I would have done the same thing. I would have gone backwards to 35 and down to 33. This is called two-tailed. And it's two-tailed is when the parameter does not equal HO. All right. The next thing, what I want us to do is state an appropriate null and alternate hypotheses. And I want you to always do the alternate first. I think it makes it easier. So I want you to get H1 first. All right, and I want you to look at this problem. It says boxes of cereal, of a certain kind of cereal, are labeled as containing 20 ounces. An inspector thinks that the mean weight may be less than this. This is your H1. Okay, so the inspector thinks mu might be less than 20. HO is no, mu is 20. Notice that the numbers are always the same. HO is always mu equals something. H1 is one of your alternates, but it's all the same number. And this is a left-tailed test. All right, the next one. Last year, the mean monthly rent for an apartment in a certain city was $800. A real estate agent believes that the mean rent is higher this year. All right, so here's what I'm going to do. I'm going to say, okay, the agent believes the rent is higher, greater than 800. HO, nope, mu is 800. And that's a right-tailed test. The next one, scores on a standardized test have a mean of 70. Modifications are made, and an educator believes that the mean may have changed. They're not saying it's better or worse, it's just different. Okay, so here's what the educator thinks. It's changed, so it's not 70. And HO is, it is 70. That is a two-tailed test. Pause the video and answer these two and then turn it back on. Letter A, it says last year the mean amount spent by customers at a certain restaurant was $35. The restaurant owner believes the mean may be higher this year. Okay, so I'm going to do the same thing. The restaurant owner believes the mean may be higher than 35. HO, mu is 35. In a recent year, the mean weight of newborn boys in a certain country was 6.6 pounds. A doctor wants to know whether the mean weight of newborn girls differs from this. Same thing. The doctor wants to know if it differs from this. And what is this, that weight of the boys? So mu is different than 6.6. HO is going to be, it's not any different. Mu is 6.6. All right, and do this one too for C. It says a certain model of car can be ordered with either a large or small engine. The mean number of miles per gallon for cars with a small engine is 25.5. An automotive engineer thinks that the mean for cars with a larger engine will be less than this. All right, so I'm going to do HO and H1. H1, I think it's going to be less than this, and this is 25.5. And HO is mu is 25.5. Notice again, the numbers always stay the same. HO, mu equals H1 alternate. Now, here's what you're trying to do with the hypothesis test. The purpose of a hypothesis test is to determine how likely it is that the null hypothesis is true. And here's what a hypothesis test looks like. At the beginning, it's similar to a criminal trial. We're innocent until proven guilty. We assume that they're innocent. The evidence is presented. If the evidence strongly indicates that the defendant is guilty, we abandon the assumption of innocence and conclude that the defendant is guilty. In a hypothesis test, the null hypothesis is like the defendant in a criminal trial. And here's what I mean. At the beginning, you're going to assume that the null hypothesis is true. So right off, you have to assume HO is true. And then what we're going to do is look at the data. We're going to look at the data, and if the data strongly indicate that the null hypothesis is false, we abandon our assumption that it's true and believe the alternate hypothesis. This is referred to as rejecting HO, rejecting the null hypothesis. Okay, so to start with, I assume it's true. I look at all my evidence, and then what I do is I either reject the null hypothesis or I don't. It's called fail to reject, and we'll get into that on the next slide. Let's look at this next example, and we're going to talk about evidence against the null hypothesis. We reject the null hypothesis when the data provides strong evidence against it. The evidence comes in the form of a test statistic. When the difference between the test statistic and the value in the null hypothesis is sufficiently large, we reject HO. Suppose an exam has been given to a large class and the instructor claims that the mean score in the exam is 80. The null hypothesis is HO mu equals 80. Now suppose that a sample of exam scores is selected and the sample mean is 78. Because 78 is fairly close to 80, it is plausible that the null hypothesis is true. And plausible is more than possible. Plausible means it's reasonable. I think the null hypothesis may be true. And I want you to look at this graph. If you look at this first graph and you look at 80 and 78, my test statistic is X bar. And when you look at X bar, 78 is very close to 80. Imagine, however, that you'd taken a sample and the sample was 50. 50 is far from 80. It doesn't seem plausible that the population mean is actually 80. We would probably reject HO in this case. So when you look at this one, look at how far 50 is from 80. That does not seem plausible that mu could be 80 and we could get a sample result of 50. So if you look at this one, I would probably have enough evidence to reject HO if X bar is 50. If you look at this one, when X bar is 78, I probably would not reject HO. But here's what gets tricky. We can see that the further the test statistic is from the value specified from HO, the less likely the difference is due to chance and the less plausible HO becomes. The problem becomes, it's easy when it's a big difference because you can tell. It's very easy. But the problem becomes, what if there's a little difference? And here's what we're going to say. How big does the difference have to be before we reject HO? And that's going to get into our math that we'll get into with the next lesson. Now, to answer the question, we need methods that enable us to calculate just how plausible HO is. Hypothesis tests provide these methods, taking into account things such as the size of the sample, and the amount of spread in the distribution. And now here's what we're going to do, and I'm going to talk to you about how to do conclusions. If the null hypothesis is rejected, the conclusion is straightforward. We conclude that the alternate hypothesis is true. If the null hypothesis is not rejected, we say there's not enough evidence to conclude that H1 is true. It's not saying that the null hypothesis is true. We're saying that it might be true. Okay, so here's what we're going to do. And this will take a minute to get it. Once you get it, it's very easy, but it will take a minute. You'll have to use your notes for a little bit to get it. Here's the same question about the inspector. And in this, say he gets enough evidence that he rejects HO. If you reject HO, you're going to conclude, HO is going to go. You're going to conclude H1 is true. All right, so here's what he's going to do. And here's how we're going to say it. We're going to say we will reject HO. And the same thing, if you like to say I will reject HO, that's perfect. I'm going to say we will reject HO, period. That's all we're going to say about HO. We have enough evidence to conclude, and you look at H1 and you conclude H1, and you do that in context. So we're going to say we have enough evidence to conclude that the true mean You want to say true mean, just like in our confidence intervals. The true mean weight is less than 20 ounces. Now, same example, but say that he doesn't get enough evidence and he doesn't reject HO. If we fail to reject HO, we can't conclude H1. And all you say about HO is we reject it or we fail to reject it. So here's what I'm going to say in this one. It's almost going to look like the other one, so you got to be careful. But I'm going to say we will fail to reject HO. HO is not going anywhere. Okay, we will fail to reject HO. And then it's going to look just like that other conclusion, except you're going to say we do not have enough evidence to conclude that the true mean weight is less than 20 ounces. All right, and that's how your conclusions are going to go. Now, the next thing I want to talk about is the types of errors. Now, when I do a hypothesis test, I hope that I'm right. Like, I want to make the right decision, but you can't always make them. And there's always the possibility, because of chance, that you make a wrong decision. And there are two ways in which a wrong decision can occur when doing hypothesis testing. You can make a type 1 error, or you can make a type 2 error. All right, and I want to look at this table. This table is going to help you with all of these problems. So here's the fact. Either HO is true or it's false. Okay, if HO is true, let's look in HO is true column. I want to fail to reject HO. This is a correct decision. If HO is false, I want to reject it. That is a correct decision. Now let's go up to the errors. And you know if it's true or false later. Like, you don't know right then when you do it, but you know after the results come in. All right, so here's a type 2 error. I'm going to start with type 2. Type 2, you fail to reject HO when it's false. And I like to do the type 2 first because you fail to. That's how I remember that. Now, type 1 is you reject HO, but it's an error. So you reject HO when it's true. Okay, so let's look at the fact. HO is true. I reject it. Type 1 error. Don't want that. HO is false. I fail to reject it. Type 2 error. Don't want that. All right, in general, a type 1 error is generally more serious than type 2. A type 1 results in a false conclusion, while type 2 results in no conclusion. Ideally, we want to minimize the possibility of both errors. Unfortunately, with a fixed sample size, as you decrease the chance of type 1, you increase the chance of type 2 and vice versa. So that's what you got to be careful of. Hypothesis tests are often designed so the probability of a type 1 error will be acceptably small. Most of the time it's 0.05, sometimes 0.01, it can be anything. This value is called the significance level of the test. All right, now here's what I want you to do as you're doing these problems. Notice that I reprinted the chart because you always want to print the chart, and it says, the dean of a business school wants to determine whether the mean starting salary of graduates of her school is greater than $50,000. She will perform a hypothesis test with the following null and alternate hypothesis. So here's what she's testing. All right, now I want you to look at what happens. Now here's what I want you to do. It tells you the answer. Okay, so here's letter A. It says the true mean is 50,000. All right, so look at her HO, and if the true mean is 50,000, her HO is true. Okay, so HO is true. All right, I want you to not look at the rest of the, don't look at that yet. Okay, I'm going to go here and I'm going to go to HO true. This is the column that she is in. Now, here's what the dean does. The dean rejects HO. She rejects HO, therefore she has made a type 1 error. All right, let's look at the next one. The true mean is 55,000. All right, now look at your HO. All right, so if the true mean is 55,000, HO is false. All right, then look at the rest. The dean rejects HO. Okay, so I'm in HO is false column. The dean rejects HO. She did the right thing. All right, the true mean is 55,000. I'm back in HO false again. And the dean does not reject HO. So I'm back up here in HO false again. And she fails to reject HO. She made a type 2 error. Type 2 error. All right. Now look at this one, and it's just more practice with this. Here's my test. And it says the true value of mu is 150. Okay, so the true value of mu is 150. HO is false. All right, so I'm in HO is false column. And HO is rejected. HO is rejected. Good. All right, this next one. Here's my test. The true value of mu is 20. So look at your HO. HO is false. All right, I'm back up in this column. And HO is not rejected. I failed to reject HO. I just made a type 2 error. And if you use that table, it's very easy to do. This one. HO, H1. The true value of mu is 3. All right, so I'm looking at HO is true. All right, so I go up here, HO is true, and HO is rejected. I reject HO. I just made a type 1 error. And that's it for our intro to hypothesis tests, the type 1 error, the type 2 error, and making the conclusions. And we will finish this up with the math with 9.2.